Software innovation has been taking off these days. You all know that with the rise of big data analytics, machine learning, artificial intelligence, the amount of data being produced, processed, and stored is really taking off. And folks who are feeling that, especially a lot, are the hosts of cloud data centers like Google. This graph shows the amount of data that has been moving between servers inside Google's data centers and how that amount of data has been growing over the past few years exponentially. Same thing at Facebook and across the industry, and I especially like these numbers from Facebook because they show the growth in bandwidth consumption and data going to and from their data centers. That's the two blue lines at the bottom of the graph. And they compare that to the amount of data moving just between servers staying inside their data centers. And that growth is really eclipsing bandwidth consumption coming to or from your phones or computers to their data centers. At the same time, the hardware that supports that communication hasn't been keeping up. So historically, the top amount of bandwidth available to move across a cable for data centers, across optical cables, has increased by a factor of 10x every 3 to 5 years. But more recently, that growth has flatlined. And it's become a bottleneck, especially with demand growing exponentially. So it results in data centers that look like this and like this. And ultimately, at its core, it's a problem of chips. So over the past few decades, chips have been getting more and more powerful as transistors have decreased in size, and as a result, processors have become more powerful. But something that hasn't been changing over the past few decades is how we get data in and out of chips. We still rely on copper pins, and it's the same type of technology we've had doing that for decades. We at Ayar Labs have figured out how to get computer chips to communicate using light instead of electricity. As a result, we're removing that bottleneck and enabling the next generation of hardware and software innovation. So this breakthrough is a result, as Patrick said, of 10 years of research funded by DARPA. They put $20 million into this, and it took place at 3 universities, as Patrick said. And the end result of replacing those copper pins with fiber optics directly to a silicon chip is that you can use 10 times less energy to get data in and out of a chip and 40 times less space on the chip to get data in and out. So that is how we're really getting rid of that bottleneck caused by copper I/O. Our first customers are going to be data centers, and specifically, it's going to be the owners of high-performance computers, supercomputers, and the warehouse-scale data centers that make up the cloud. So these guys are ideal first customers for a few reasons. First, they have a huge need for this, as I showed in those graphs earlier. Secondly, they're already really familiar with optical technology. They're already using it inside their networks. And third, they tend to lead the way in adoption of new technology and really signal to the broader data center community where the industry is going. Our first product is going to go inside switches that are inside these data centers. It's going to be a tiny 1.6 terabit per second optical transceiver that'll go inside switch boxes. And when you compare it to what we expect competitors to have when we come out with our first product, having this silicon chip at the core of our transceiver enables it to use 2 times less energy than competitive products, and we expect it to also be 5 times more reliable than anything else that will be available. We already have interest from a bunch of different companies, including owners of cloud data centers, a lot of the national labs that build some of the world's biggest supercomputers, as well as a lot of the companies that supply hardware to those data centers. But ultimately, we don't want to just be selling optical transceivers to data centers. We want to get every chip communicating using light. And we're going to do that by licensing IP to all of the companies that make computer chips, ultimately getting into CPUs, GPUs, DRAM, and beyond. And we can use our technology not just for communications, but also for applications in sensing. For example, we want to go into LiDAR eventually, replacing the big mechanical systems that spin around on top of self-driving cars with a tiny system on a chip. That's just one example of the really incredible things you can do with this technology. So our team is made up of the inventors of this technology out of that DARPA project, and we're joined by the 3 professors, part-time, whose labs the technology came out of. More recently, we've hired some industry veterans from Micron, Lumentum, and Intel. And Roy, formerly from Micron, who's our VP of Manufacturing, is here tonight, so you can talk to him and me afterwards. We also have gotten some funding, both from government grants, the biggest of which was winning the MIT Clean Energy Prize last year. And we've also raised equity funding. We raised a seed round led by Founders Fund. It was $2.5 million. We are planning soon to raise a second seed, so if anyone here is an investor and is interested or knows someone who might be, come chat outside afterwards. Thank you.